Okay, folks. So today we are going to do sort of two-step calculations where we have to use our two equations kind of put together. So let's look at our problem and then let's figure out how we want to approach it. There's actually two ways to approach this. I'm going to show you both. So what is the energy of a photon of light that has a wavelength of 4.56 times 10 to the 9th meters? So the first thing we always want to do is make a list of what we know. So the problem they told us the wavelength is 4.56 times 10 to the 9th meters. They are asking us to find the energy. All right, now this is slightly problematic because if we look at our two equations, we have the speed of light is equal to the wavelength times the frequency. And I do know that the speed of light is 3.0 times 10 to the 8th meters per second. But in order for me to solve this, I'm trying to get to energy. And there's no energy in this equation. So I could certainly put my wavelength and my speed of light in here, and that could get me the frequency, but they're not asking for frequency, they're asking for energy. I have another equation, energy is equal to Planck's constant times the frequency. And I do know Planck's constant. Planck's constant is 6.63 times 10 to the negative 34th joules seconds. So I know all of these things. But if you're paying careful attention, you will notice that I'm going to have to use both equations. Because I have wavelength and speed of light, that can give me the frequency. Once I have the frequency, I can then use the frequency and Planck's constant to get me the energy. So there's a couple of different ways that I could do this. The first is very much algebraically. So let me show you what I mean by that. We have these two equations. Okay? I want energy. And the one thing that these two equations have in common is F. So if I solve this equation for F, I can say that the frequency is going to be equal to the speed of light divided by the wavelength. I can then substitute this in for frequency in this equation. So I can rewrite my energy equation. Energy is equal to Planck's constant times the speed of light divided by the wavelength. Okay? Now, I have Planck's constant, I have the speed of light, and I have the wavelength. So once I have this equation, I can then go ahead and substitute in my values. So for Planck's constant, I have 6.63 times 10 to the negative 34th joules seconds. Remember, we must put our unit. This is science, not math, and we have to show how the math applies to the unit. We're going to multiply that times the speed of light, 3.0 times 10 to the 8th meters per second, divided by the wavelength, which is 4.56 times 10 to the 9th meters. Now we're going to stop here and remember that we have to apply our math not just to the numbers but also to the units. So I have meters over meters, so that can cancel out. And then if you're paying careful attention, I have seconds over seconds, because this is in a fraction. So I can cancel out my seconds. That leaves me with nothing else but joules for my answer. So then I go back and I say, okay, is joules an acceptable unit for energy? And the answer is yes. So now I can very easily go into my calculator and put in my numbers. Remember though, when we're using this times 10, we want to use our special second function comma buttons. So I'm going to put this in as 6.63 second comma negative 34. And I'm going to do the parentheses. So I'm going to do an open parentheses, 3.0 second comma 8 divided by 4.56 second comma 9, close parentheses, and hit enter. That's going to get me a value of 4.361842 blah 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 e negative 35. I'm going to round that up to 4.4 times 10 to the negative 35th joules. Okay? So that is one way to do this. Now I'm going to leave that answer there, and I'm simply going to go back and erase. Okay? So we have that the frequency is equal to the speed of light divided by the wavelength. Frequency is equal to the speed of light divided by the wavelength. Let's go ahead and substitute in those values. 3.0 times 10 to the 8th meters per second divided by our wavelength, which was 4.56 times 10 to the 9th meters. We have meters over meters. That will cancel out, leaving us with, careful, 1 over seconds. So we're going to do 3.0 second, comma, 8 divided by 4.56 second, comma, 9. And that is going to get us a frequency value equal to 0.0658, oops, I can't read, 5, 7, 8, 9, 4, 7, 3, 7. Now you'll notice that I did not choose to round this one because I want to end up with the same answer that I had over here. Okay, now if that is my frequency, I'm going to take that frequency and I'm going to put it in here. So I'm going to take just that number and I'm going to multiply it by my Planck's constant. So I'm going to take this number and I'm going to multiply it by my 6.63 times 10 to the negative 34th joules seconds. This is in per seconds. So seconds over seconds is going to cancel, leaving us with joules. So I'm leaving my number exactly as it is in my calculator. I'm going to multiply it by 6.63 second, comma, negative 34. And that gets me 4.36184 blah 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 4.4 times 10 to the negative 34th joules. Okay, so you may solve these either way. You may either solve them algebraically and substitute the equation in so you only have to put numbers in once, or you can do solve for one equation first and then plug that number into the second equation. The only catch if you do that is to make sure that you don't round the number between or you're going to lose precision in your answer. All right, so let's look at another example. What is the wavelength of a photon of light that has an energy of 7.1 times 10 to the 23rd joules? So in this equation, they've given us the energy of 7.1 times 10 to the 23rd joules. And they have asked us to find the wavelength. Okay, so we are going to take our two equations. We have energy is equal to Planck's constant times the frequency, and we have the speed of light is equal to the wavelength times the frequency. Okay? This case, we're trying to solve for wavelength on this one. So let's go ahead and solve this one for wavelength. We're going to divide both sides by the frequency. So the wavelength is going to be equal to the speed of light over the frequency. So this is what I'm trying to get to. Now over here, I'm going to solve this for frequency. So the frequency is equal to the energy divided by Planck's constant. Now what I'm going to do is I'm going to substitute in this for that. Okay? So my wavelength is going to be equal to the speed of light divided by the energy over Planck's constant. Okay? So now I can simply plug in my numbers and solve. So for my speed of light, I have 3.0 times 10 to the 8th meters per second. For the energy, I have 7.1 times 10 to the 23rd joules. And then for Planck's constant, we have 6.63 times 10 to the negative 34th joules seconds. All right, so I have joules over joules. I have 1 over seconds divided by 1 over seconds. So that's going to cancel, leaving me with meters. That does make sense for wavelength. All right, so in my calculator, I'm going to do 3.0 second, comma 8, divided by parentheses, don't forget that parentheses, 7.1 second, comma 23, divided by 6.63 second, comma negative 34. And that should get you 2.8 times 10 to the negative 49th meters. Okay? So that's one way of doing it. That's the algebraic way of doing it. So now we can also go back and we can simply substitute in values for each of these equations. So for this equation, energy is equal to Planck's constant times the frequency. Let's solve that for the frequency. Our energy is 7.1 times 10 to the 23rd joules over Planck's constant, which is 6.63 times 10 to the negative 34th joules seconds. Joules over joules will cancel, leaving us with 1 over seconds. So 7.1 second, comma 23 divided by 6.63 second, comma negative 34. Again, I don't want to round this, so I ended up with 1.07088898994 times 10 to the 57th. That's per seconds. Now, I want to do my wavelength is equal to the speed of light divided by the frequency. So I'm going to take this number that I just got, and I'm going to put it on the bottom of my fraction, and I'm going to put the speed of light on top. My per seconds are going to cancel, leaving me with meters. Now to put this into your calculator, there's a little bit of a trick, so that I don't have to type all of that messy number out again. I'm going to do 3.0 second, comma 8 divided by, and then I'm going to hit second function, and then the little negative button is going to use my answer from the previous problem. So you should get a little A and S on there if you do that. And that gets me 2.80140 blah 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 times 10 to the negative 49th meters. So both ways of solving are perfectly valid.